Good morning. Today's our last lesson in Chapter 7. This is 7-3, solving exponential equations. So the solving of exponential equations potentially uses logarithms, but in this chapter we just try and do it without. So you'll see how we can work around this thing. But I have taught you how to solve using logarithms, and I do expect you to solve using logarithms for some of the questions that we do. But not in this section. You should never have to use logs in this section when you're solving. So it's going to be solving by equating the bases like it says in number 2. Before we do that, we have to do a tiny review on exponent laws from grade 9, grade 10, whenever we do those things. So let's have a look at exponent laws, or let's look at this first little question maybe to help us understand exponent laws again. First of all, it says write each expression as a single power of, it should say of base 2. So the power of 2 it could say, but I guess it should probably be more accurate to say base 2. So base 2 means that you should, when you write down this final answer, it should say 2 to the power of something, right? Every one of these should say 2 to the power of something. So that's what they're saying. You should have a base 2. Now this is going to help us when we're solving by equating bases. You'll see pretty soon. So if we're doing this first question, it's half is the same as, or 0.5 is the same as a half, which is the same as 2 to the negative 1. And you can see that we now have expressed 0.5 as a power with base 2 by writing it as 2 to the negative 1. Okay, so that's that one. If we want to have root 32 the same way, we have to do a couple of extra steps. You have to remember some of these. First of all, we can say that this is the same as the root of 2 to the power of 5, because 32 is 2 times 2 times 2 times 2 times 2, 5 2's multiplied together. And if you remember from back when we first learned these things, grade 10 I guess, we also know that square roots can be written as the power of a half. And then there's this law we have, which I'll do in red over here, this law where we can say x to the m all to the nth power, we would multiply and we would end up with x to the mn. So you have to remember that rule because that's the one I'm going to use right now to finish this question off. And that's where I say this is the same as 2 to the power of 5 over 2. So 5 times a half is 5 over 2. And again, I've written as base 2 power. Now sometimes in this chapter you're going to be looking at a section, you're going to be looking at it going, I think 512 is a base 2 power, and you might have to pull out your calculator to play a little guess and check, or Price is Right. So you know, I know from the past that 2 to the power of 9 I think it is, so I check it real quickly and I can just write it as that. So sometimes there's big numbers that we don't necessarily know offhand, but they could be base power 2, so we can check that. And you can just go through and do a table of values, 2 to the power of 1, 2 to the power of 2, 2 to the power of 3. Eventually we got 2 to the power of 9, which is 512. And then lastly we have this fractional one. Let's kind of go through this one. This is the same as, I'll go through the steps. I'll do a little step at a time here. 1 over 2 to the power of 4 to the 5th power, which is the same as 2 to the power of negative 4 to the 5th power, which is the same as 2 to the power of negative 20 when we multiply those together. So again, that 1/16 is 2 to the power of negative 4. You might have been able to jump directly to that. I'm not sure where you're at in doing these things, but that's definitely the rule that I'm using. Now the other two rules are when combining things, and we're going to get into them when we're solving equations below. One of them was this: we have bases that are the same, x to the power of m, and we multiply by x to the power of n, we get x to the power of m plus n. Remember, we add the exponents. And the same if we do division, or if it's written as a fraction. This is when we subtract those exponents. Okay, but this could also be written as x to the power of m over x to the power of n, which is still division. So really we have these rules These are the basic rules. And this rule are our basic rules that we use for everything in exponent laws. And we have to use these when we're solving exponential equations. So let's have a look at this question here and see how we do. So solving by equating the bases means that what we want to do is have the same base on either side of the equal sign. And 16 and 8, if you look at the two bases that we have there presently, are both base 2 numbers. In other words, base 2 numbers are 2, 4, 8, 16, 32, 64, and so on. So doubling by 2's. And also into the negatives if you want to go that way as well. But what we do in these questions is we change, just like we did in question 1, is we change those numbers, like 16, into a base 2 number, because we recognize that 16 is a base 2 number and 8 is a base 2 number, and that gives us the opportunity to do what we're going to do in this question. And this is how we get through these questions and make them work. So 16 would be the same as saying 2 to the power of 4, and that's still brought to the x plus 3. And this 8 is 2 to the power of 3, and that's all brought to the 1 minus x. And then we're going to use the rule that's directly above here, this one, the xm to the n power. This is just 2 to the 4 to the x plus 3 power. And we're going to multiply those two things. And we're multiplying a monomial to a binomial. So we end up having 2 4x plus 12 equals 2 3 minus 3x. I just multiplied the 3 into the binomial and multiplied the 4 into the binomial. Now here's the kicker. Now that we have the bases the same of these two questions, we can do this little therefore statement. We say, well, look, if we can make those bases the same, then we can say, well, those exponents must be the same. So we can just go 4x plus 12 must be equal to 3 minus 3x. And I'm just going to write down beside this, therefore, and I'm just going to put down an arrow here, because the bases are equal. Now we can do this that's why we can do the statement. So we have to strive to get them to be the same. So right here, I'm not crossing them out, I'm just showing this and this are the same right now. And that's why I'm able to do what I'm doing. Okay, so I'm able to say now that I have this now, I've degenerated down to a grade 8 question after we get to this. So this is only the grade 12 part, is getting it so you have base something equals equal base something, and once we're there we can just say therefore the exponents must be equal. And now we can finish off the question. This will be 7x equals negative 9, so x must be equal to negative 9 over 7. Now the cool thing or the good thing about this is you don't have to really, if you did all your algebra correctly, you don't have to really worry about, there's no domain restrictions in here. You can have any value of any exponent value. Remember, the domain is all real numbers, so that shouldn't be an issue. So you don't have that to worry about, but you can always double check by substituting it back into the question and verifying that it's the correct answer. Okay, so that's the correct answer though, unless I made a mistake, but I don't think I have. So let's have a look at the next question. Now these ones get a little more confusing because we're going to have to use the second bubble up above, the one that's directly above, to do some of these questions. And we have to know our exponent laws quite well to do them well. So the first thing we do is we take and it helps sometimes for students to see me separate these two. This is 3 to the power of 4x, and it's being multiplied to 3 to the power of 1. That's what 3 is. And it's important to see them both as power base 3. And over here I have 3 to the power of 3 all to the 2x. In other words, I'm taking that 27 and making it also base 3. And you can see that everything is base 3. Now I can't do the therefore statement I did before in A until I have 3 to the power of something equals 3 to the power of something. I can't have three bases here. I just have 2 bases, one on either equal, 2 powers, one on either side of the equal sign. So this first one I have to use my exponent laws to put them back together. So it's going to be this, right? Because you add when you multiply, so 4x plus 1, and then 3 to the 6x. So you can see that if you didn't understand that 1 existed, you would have maybe some trouble getting that 4x plus 1. But now we have 3 to the power of something equals 3 to the power of something, therefore something must be equal to something. And now we're off and running on this level again. So this will be minus 2x equals -1, so x equals half. Right? So there's our second answer. Okay, but I had to do a little bit of exponent law stuff. Okay, last question. We keep these pretty, it's a nice little part of this thing. This equating the bases is not too bad. We're not having to do logs yet. They get a little hairy next chapter. Okay, so 1/9. We have 1/9, 27, and 9, which is all base 3 numbers again. So I'm just going to rewrite some of these. So 1/9 is 3 to the -2, all to the x. 27 is 3 to the power of 3 to the x. And 9 is 3 to the power of 2, all to the 2x minus 1. So you can see again that I've put all of the numbers, the different things into base 3s. Now I'm going to do power to a power rule, which is going to be 3 -2x equals 3 to the 3x all over 3 to the 4x minus 2. All right. So my left-hand side is fine, but my right-hand side I have a division. In division we have to subtract. So this is going to be 3 to -2x, and then it's going to be 3, and I'm going to go 3x, and I'm going to go minus 4x minus 2. Now it's critical that you put that binomial below into a bracket because you're subtracting, and when you subtract a binomial or a trinomial or any polynomial that has more than one term, you're going to have to distribute that negative in. So just to continue on with this question, now we're going to have 3 -2x and 3 to the 3x minus 4x plus 2. Now it's critical that plus 2 is what I see too many students make issues with. I could explain this question every year, and every time I put a question like this on the test, I get the same issue. They forget, I'll get 25% of the kids forget to change that to a plus 2. 3 minus 2x. Now I'm just going to simplify that side, so it's going to be 3 to the -x plus 2. 3x minus 4x is -x, and then just plus 2. Now I can go therefore, because I have 3 to the power of for both of them. That. Collect my x's on the left. Divide by -1. And I'm done. Okay, you can always verify again by taking those and putting them back in. So, there's the 3 basic solving by equating bases questions. There's some other ones in the book that you can try. You can see that I'm using those red clouds that I put above. I'm using those rules in a variety of different ways, but I'm very confident with my exponent rules, and you might be a little rusty. So make sure you practice, and if it was a test coming up, instead of just a show you'd make sure you'd practice over and over again so you knew conceptually what's going on. Here you can kind of just follow my lead when you get to the test by looking back at these notes. But yeah, make sure you don't make any silly mistakes that are grade 9, grade 10 mistakes when you're doing this stuff. The only really, honestly, the grade 12 stuff is the therefore statement. That's the new thing. Other than that, we're doing a lot of stuff that was grade 9 and grade 10 in here. Okay, so now we're going to just go through here, and I wanted to go back and look at 2 things I usually do in this thing is just to review 2 things. We'll review one thing and then teach you something about compound interest, but I think we're going to skip compound interest this year, so we're going to leave that out. So here, let's have a look at just 3 then, and maybe quit after 3. So this was just to remember to solve by logarithms. So I wanted to redo these ones and show you how to get through it, and we'll make this work. Now I'm just going to add something to this. I'm just going to put -5 here. So I'm going to change the question a little bit. So we have all things involved. Okay, so I just made it 3t minus 5. So you can look at that. Hopefully when you get you look at these notes, you see that I've changed the question. So I'm going to write maybe a star here. So if you're not listening to me, you can see that I've done this. Question has been changed. Okay, so when we can't equate the bases and we have a variable in the exponent, oftentimes we have to use logarithms. So we've done this already. So just to refresh, just to review what we've done a little bit before, because you will have to do this a few times on your show, you know, is there's the power portion, which is this portion right here. That portion needs to be isolated first. So when we look at a Firth equation, for instance, we need to put the f and the I together. That's the first thing that we have to start kind of by doing. So that's what I do at the beginning of this question, is I would take 5 and I would divide it by 200. And then I would have now on this side half to the 3t minus 5. Okay, so that's good. So you can, if you wanted to, you could take that 5 over 200 and you could reduce it to 1 over 40, I believe, right? So 5 divided by 200 is going to make sure. So you could do that if you want to. I generally don't, to be honest. I will just leave it the way it is because there's no point in doing it. So you can reduce it if you want, but don't. What you can't do is get an approximate value and then cut it off to too many decimal places, because remember how the curve works, right? Asymptotic, doesn't change very much, but when it gets to the exponential part of the curve, there's this very steep curve, and if you approximate a value, you potentially are throwing t off into a very different thing. So I'm just going to put here that we're going to keep this value exact. So must be kept exact. And again, that's got to do with the way the curve runs. We are worried about having approximating and having that curve, that x, by you just changing the values by a little bit, you can move that value, x value, quite a terrible amount. So we don't want to do that. Okay, so that's first of all. So just always keep that exact. Now the second thing was I taught you how to change form. So change form was a very handy thing. What we do is we write log. The base that was on the other side, which is half, becomes the base of the logarithm. And then we have 5 over 200 here is equal to 3t minus 5. That becomes now drops down. Now there was different ways that I showed you by logging both sides, but this is the easiest way for you to remember. So what I've done is I've taken the base of the logarithm, which is half right here, and I've made it the base of the power, and I've made it the base of the logarithm. So when they change sides and we change forms from exponential form to logarithmic form, the base of the power becomes the base of the logarithm. That's what you need to remember. And you can go the other direction too. We just don't in this chapter yet. But always the base for logarithms and base for powers is the same base because it's opposite operations. Now, for some of you, you'd be ready to punch stuff into your calculator right now because you have the, remember what I said, you have a button on your calculator that looks like this. Log with a box and another box. If you have that, you can put in what we have already, but I don't have that. I just have a what's called log base 10 button, which just looks like a log button. So what I have to do is one more of my log rules. So this is, I've basically taught you 2 log rules right here. 3 if you look back and see the one where I drop the exponent and make it the coefficient, which is another rule that's very important too. But in this case, I have another log rule because my calculator doesn't have the button with the 2 boxes. It just has the log button, which is log base 10. So I have to split these 2 logarithms together apart and make them this one log and make it 2 logs divided into each other. So the one that is the base becomes the denominator, and the one that is the thing that's being logged, 5 over 200, becomes the numerator. And what we've done is we've changed it from a log base a half to being 2 log base 10s. When you don't, just like when we have a square root, we don't write the index 2. When we write just log, we're assuming that the base is 10. So what we've done is we've changed the base to base 10 and to be able to use it with our calculator. So both of these are calculator ready, and that's what we need to get to. So I'm just going to write calc ready, but not this one, not for me. This is also calc ready. And the whole point of this is we have to get to a point where we're calc ready. Otherwise, we're going to have issues with these questions. So I'm now calc ready for me. You might have not done this extra step because you were already calc ready before. So it doesn't matter really. So 3t minus 5 here. Okay, so now I encourage you to actually punch that into your calculator. So I'm going to do that, and you can try that too while you're sitting there to make sure you know what you're doing with your calculator, because you got to try a few things, make sure you're not making mistakes. So I'm doing log of 5 over 200, or 1 over 40, or the decimal 0.025, or whatever you want to do. But the key is you want to have that exact value, is what I said above. And when I get that, I end up with 5.322 approximately. So I'm going to put an approximate symbol here. Now I'm going to add 5 to both sides, which will make 10.322. That's approximately equal to 3t. And then I'm going to divide both sides by 3. So t is equal to, add 5 to that, and I'm going to divide by 3. Now I don't actually approximate anything to the very end, by the way. I'm using exact values until this step right now. So I'm just leaving everything in my calculator, and I end up with, I think they wanted this to 2 decimal places. So I'm going to leave this now as 3.44. I'm just going to rewrite it so that it's not Yoda talk. And that's good. Now you can try that again if you really want to see if it works or not. You can go back up here and put, to verify, you can put 3.44 here and see what happens. And if you do, you should end up with 5. So I'm going to just try that real quick to make sure that it worked. So make sure that you put the power in brackets, by the way. The exponent in brackets. So 3, I put bracket for the, I go to the power of and in bracket 3 times 3.44 minus 5. I press enter and I get 5.006686. So because 3.44 is approximate, my answer on the right hand side of the equal sign is going to be approximate. So I can't say it's exactly equal to 5, but it should be very, very close, right? So that's how you verify in these things. You can always double check your answers. So I just took my 3.44 and I put it in to verify and made sure that left side was approximately equal to the right side. It should be very close, right? Because 3.44 is approximate. So that's your finish. I think I'm finished with exponential stuff. Now the bottom has 4 and 5 are both compound interest. I think I took them out of the outline. So we're going to omit compound interest for you guys. In our case, we're going to omit those, and we'll, if we we'll learn that at a different time if you have a chance to. But right now, I think I'm just going to take it out because it's a little bit weird and confusing, and it takes a while to get through. And it's very helpful if I'm actually sitting in front of you doing it. So we're going to skip that part of the exponential stuff. So if you do find a compound interest question, which I think, like I said, I took out of the C19 outline. If you find one of those, you can just omit it yourself, but I think I didn't. It's not like you have to show me that homework anyways, and on your test there won't be an exponential question that has to do with compound interest, okay? It is interesting to learn, but I'm not going to do it. So that's your last lesson for 7.3. Tomorrow I haven't created your show you know yet, so tomorrow I'll probably make your show you know so you have that sitting in front of you to work on next week. You can have the week to work on that. And then we have one more very tough chapter to do with the logarithms, and then we're done, I think. We have one more chapter potentially, so we'll see how things are working out. And when, time-wise, we have actually this 7, 8, and potentially we should probably do a little bit of 9, but it's not out as very, it's not as super hard chapter, so it's just 8 is going to be difficult to learn. So that's the one we have to really worry about. Okay, so have a great day. We'll talk to you later.